matrix operations in your calculator. First of all, you're going to need to enter these matrices in to your calculator. Let me remind you how to add a matrix into your calculator. You press the matrix key, that's second matrix. You go over to Edit. You press Enter. If it's a 3 by 3, you press Enter, 3, 3, and then you can go ahead and enter the values. For example, 1, Enter, 2, Enter, 1, Enter, and then it goes down to the next line and so on. So you need to enter all your values in. Here are the 4 matrices that we're going to operate on, so you need to stop the video now and type these in. Obviously, you're going to go over here to Edit, and you're going to edit part B, or matrix B, matrix C, and matrix D, just like I have already done. Okay? So stop the video. I'll give you a second, and then I'm going to start going ahead. Okay, here we go. So we're interested in the operations that are over here in this column. It's really pretty straightforward. It's just like doing arithmetic in the calculator, regular arithmetic with real numbers, except you're going to use matrices in there instead. So for example, if you just want to do A plus B, you got to do second matrix, and then you're going to use the names right here, the names column, which is the first column, to pick out the name of that matrix. So A in this case, plus second matrix B, and then enter. That's as easy as it gets. It's quite trivial, and you can do larger matrices obviously pretty quickly as you can enter the matrices in. So how about the second one? That's not too bad. Second matrix B minus second matrix A, and we needed to insert in there, second insert a 2 times. So it's easy to do scalar multiplication. You just do the scalar times your matrix. And there's that computation. How about A plus C? Second matrix A plus second matrix C. And you see it's very smart. It knows when you have a dimension mismatch. You need to recall that for addition of matrices, they must be the same dimension, and you can clearly see that A and C are not the same dimension. How about A times B? Pretty straightforward. Second matrix A times second matrix B, and there you get that. How about A times C? Second matrix A times second matrix C. That's also good. Notice how, even though they're not the same dimensions, the columns of this matrix are the same as the number of rows of this matrix. So that's all it needs to be in order for multiplication to be successful. So if I just take this away for a second, you can see that A times D is not going to work. C times D will work because this is the same dimension as that, but D times C is not. So I won't do these in the calculator, but the calculator would tell me either the answer or whether it was a dimension mismatch. Okay? So, well, let's just do a second matrix A times second matrix D, just so you see in the multiplication case that you also get a dimension mismatch. But the final one I want to work on is this one, which is actually the inverse. Many of you know that the inverse calculation is quite complicated even for just a 2 by 2, but it's very simple to do in the calculator. You bring up the matrix you want to take the inverse of, and then you simply hit the inverse key, the reciprocal key, which is really the inverse key, as you should know now, not the reciprocal key, the inverse key. Okay? And there is the entire matrix. Of course, you can't see it all on the screen at once. You have to scroll back and forth. Same dimension as the original one, 3 by 3. You know, if your matrix got significantly large, which you really couldn't type easily into this calculator, you discover that this inversion processes could be quite time-consuming. But for small ones, the calculator can easily compute the matrix quickly, or the inverse of the matrix quickly. That's it.